Everybody, in this video we're going to cover some useful math-related constants and methods that you may be interested in as a beginner. Then at the end of this topic, we'll cover a few exercises. Let's begin. If at any time you need the value of pi, there's a built-in constant of the math class. So I'm going to print the following. Math, with a capital M, dot pi, all capital. So that would give you the value 3.14 and some change. So instead of creating a variable for pi, it's always available to you within the math class. You just have to access it. There's also E. Math.capital E. This is the exponential constant, also known as Euler's number. You may never use this, but it's available to you in case you do. So again, access the math class, dot the name of the constant. This time, let's create a double variable named result. Here's a few methods. I'm going to reassign result equal to access math dot. To raise a base to a given power, you can use the pow method. Let's raise 2 to the power of 3, then print it. Let's print our variable result. 2 to the power of 3 would be 8. And again, I'm using a double. That's why we have the decimal portion. 2 to the power of 4 would be 16. 2 to the power of 5 is 32. Pow, meaning power, you can raise a base to a given power. These can be values or variables. There's the absolute value method. Math.abs for absolute value. What's the absolute value of negative 5? That would be 5, positive 5. Basically speaking, the absolute value method gives you that number but positive if it's negative. Think of it as the distance away from 0, if that helps. For square root, there's a square root method. Result equals math.sqrt. What is the square root of 9? I did make a spelling mistake here. If you're accessing the math class, make sure it's with a capital M. So the square root of 9 would be 3. We can also round a number. Again, access the math class. Use the round method. Let's round 3.14. Round will round a number to the nearest whole integer. Again, we're working with a double, though, so that gives us 3.0. To always round up, there's the ceiling method. Math.ceil. Again, I accidentally used lowercase m. It's capital M. Let's round 3.14 up to the ceiling. So 3.14 rounded up is 4. To always round down, you can use the floor method. Math.floor. So this time, let's round 3.99 down. Normally, it should round up, right? So 3.99 rounded down is 3. You can find the max between two values, or variables. Math.max method will have two numbers, which are comma separated, 10 and 20. What is the max between these two values or variables? The greater number is 20. There's also min. I'll just copy this because I'm lazy. Replace max with min. What is the minimum value between these two values? That would be 10. So those are a few useful math methods and constants that you may be interested in. We're going to cover some math-related exercises if you would like additional practice. In this first exercise, we're going to find the hypotenuse of a right triangle. You can follow this formula. C, the hypotenuse, equals the square root of a squared, one of the sides, plus b squared, the other side. We're going to accept some user input. We'll need a scanner. We need to import the scanner class. Import java.util.scanner. Then we'll create a scanner object. Scanner equals new scanner. then place system.in within the set of parentheses. Then when we open a scanner, it is a good idea to close it, so we don't leave any resources open. Scanner.close. We'll prompt the user to enter in the length of side A and B. Let's declare those as variables. Double A, double B. We'll also declare double C. That will store the hypotenuse. Double C. We'll need two prompts. I will use print instead of print line. Enter the length of side A. Within side A, within our variable of A, we'll assign it to scanner.nextDouble. Let's do this with side B. We can copy these two lines, paste them, replace A with B. That is lowercase b. Let's do a test run just to be sure that these two work. Temporarily, I'm going to print A, then B. Enter the length of side A, 3, B will be 4. These work. I just wanted to test that. It is a good idea to test your code as you're writing it. Then we have to follow this equation. C equals math.square root of a squared plus b squared. There is a square root method within the math class, but we have to raise side A to the power of 2 plus b to the power of 2. Here's how we can do that. So within the square root method, we're going to raise a to the power of 2 first. Math.pow, to raise a base to a given power, raise a, comma, to the power of 2. Plus, again, math.pow, to raise a base to a given power, b to the power of 2. And that's it. So let's display whatever c is, the hypotenuse. The hypotenuse, I'll write that this is C, side C, is the following, plus C. If side A is 3, side B is 4, side C should be 5, which it is. If you would prefer, we can add a unit of measurement, such as centimeters or inches. So after side C, add cm for centimeters or in for inches, whatever you prefer. So let's try that again. Side A will be 4, side B will be 5. And side C is this really long number. We haven't talked about the printf statement yet. Using printf, you can display a given amount of digits, but we do have centimeters at the end, which is what we were looking for. So let's try 3 and 4, and that gives us 5 centimeters. All right, let's cover another exercise. Given the radius of a circle or a sphere, we'll return the circumference, the area, then the volume. That's if we're working with the sphere, given the radius. So be sure that we're importing our scanner at the top, and we'll create a scanner object. Scanner equals new scanner. System.in, then be sure to close your scanner. Scanner.close. We'll prompt the user for a radius, because we need a radius to work with. We'll create a variable. It will be a double named radius. We'll declare it, but not yet assign it. We'll prompt the user using print instead of print line. Enter the radius. Then we will assign our radius variable. Radius equals scanner.nextDouble. Once we have a radius, we have to follow these formulas. So we need a circumference, area, and volume. Let's declare those at the top of our program, but assign them later. Double, circumference. I think I spelled that right. Double area, double volume. We will calculate the circumference. Here's the formula. 2 times we need pi to work with. Instead of typing 3.14159, so on and so forth, we can access that from the math class, math.pi. Pi is always available to us. Then multiply this by the radius. Let's perform a test run. I will display the circumference. The circumference is plus our variable of circumference. Then I'll add a unit of measurement afterwards. Centimeters is good, or whatever you prefer. Enter the radius, I'll enter in 5. The circumference is 31.4 centimeters. In the future, using printf, we can limit the amount of digits that are displayed. I'll show you how to do that later on in this video. Then we need the area. Area equals, here's the formula. Again, we need pi. Pi is always available to us, math.pi, times our radius to the power of 2. So we need the power method of math. Math.pow, raise the radius to the power of 2. And I'll just copy this line because I'm lazy. The area is our variable area. Now, when working with an area, the unit of measurement is going to be squared. So we can raise it to the power of 2, or you can use superscript 2. If you're on Windows, make sure numlock is on. Hold Alt, then on the numpad, type 0178 for a superscript of 2, if you would like to use that instead. So now, what is the area? Enter the radius 5. The area is 78.53 centimeters squared. Then we have volume. If the radius is for a sphere, we're going to assign our variable volume, then follow this formula. 4 divided by 3 times pi times radius to the power of 3. 4 divided by 3, we should probably make these doubles, times math.pi, and again make sure the m is capital, times our radius to the power of 3. Math.power method, raise our radius to the power of 3. Then display the volume. The volume is our variable volume, centimeters cubed. For a superscript of 3, make sure numlock is on, hold Alt, then type 0179. That's if you're on Windows. Alright, let's print the volume. Again, my radius is 5. Then we have the circumference, the area, and the volume. And the unit of measurement is centimeters cubed. Now, we haven't talked about the printf statement. We could display just a few digits. Here's how. Again, this is a future topic. Replace print line with printf. Instead of adding plus our variable name, we're going to add a placeholder, %f, to display a double. But if you would like one digit between the % and f, type 0.1. So let's do this with area and volume. Replace the plus with a comma. Then instead of adding plus centimeters, after our placeholder, add cm. Then centimeters squared, and centimeters cubed. Then we can get rid of the portion where we add the centimeters to the end. So let's say the radius is 5. Then we should add a new line character to the end of each of these. That looks much better. We're only displaying one digit after the decimal. Again, don't worry about this. This is a future topic, the printf statement. But if you would only like to display one digit, that's how you can do that. Again, we'll cover this later. Alright everybody, so those are a few math-related constants and methods that you may be interested in as a beginner.